Hi everyone. Do you miss me? I do miss the weather back there at least. It's minus 10 degrees right now here in Billings, and I don't know what it's like in Newbury at the moment, but I'm guessing it's a little bit warmer than that. Um, I know that Dr. Hassan has been trying to get everyone to start teching uh, some of their homework assignments. Maybe, I don't know if you guys are doing selected problems out of homework assignments or entire assignments, but it's a good thing to learn how to tech. I'm sure in your other classes where you write reports or papers that you guys type the assignments and you put them in a professional typesetting format. Mathematics is no different. And the ubiquitous, most commonly used language, especially for any people doing math under the age of 40, is some version of tech, whether or not it's LaTeX or it's tech embedded in some, you know, other format or in an online cloud-based system like what we have here. And so you can see already that I've created a project for all of you to participate in and to be able to get your feet wet and started on teching. And once you get used to it, it's really not very hard to do. So let's go inside and take a look what's in here. So it's paused or stopped because there hasn't been a lot of activity in it. In fact, I can see that none of you have actually done anything in here. And so here I have a stupid little tech file that I made just saying hi to Dr. Al Hassan here. See, it says hi Nasser, and that's me as the author here. And this is the very, very basic bones format of what a tech document looks like. There's all sorts of preamble type stuff, and most of this you can ignore. Title, the author, and then the beginning of the document, the ending of the document, and everything you want to write here. And here I have some text written, and it appears in this PDF on this side. So for something a little bit more sophisticated, this is the final exam I gave in abstract algebra when I had the class a couple years ago. And it looks kind of intimidating, but really, again, there's a bunch of preamble stuff that you can mostly ignore. And then the beginning of the document, uh, some stuff, the BF here stands for boldface, so you can see that these things are bold, and then the math formatting here. Now, this doesn't format it super well because it didn't actually intend for any people to read the tech code when I wrote it, but it's a good place to start and get a sense of, what a certain command looks like. So let G sub 1, G sub 2 be two groups isomorphic to each other. And over here I have let G sub 1, G sub 2 be two groups isomorphic to each other, and so on. So if you want to get started on a new document, my suggestion here would be to not reinvent the wheel. So what I'm going to do here is copy all of this. Say new tech template or whatever you want to call it. And let's say it's a LaTeX document. Let's delete all of this. I don't like that. Post that there. See, the nice thing about these cloud-based systems is that every time you save it, and it'll think a moment and it'll retypeset your document on the side. So I just copied and pasted what I had in the other document, and boom, this stuff looks exactly the same. And so what I want to do now is I'm going to delete everything before the new document. I'm going to save that. It's going to leave me like a blank page here. Give it a moment. I don't think it really wants to display a blank page so very much. So let's start editing it, and it should translate into something useful on the side here. So let's say the title of our thing is going to be, no, what should we call this? Tech demonstration. Say the author is going to be me. And let's start this thing by making the title. That way it's not totally blank. And if I save that, there we go. Tech demonstration, TNG, February 20th, 2018. All right, so let's first get some things out of the way. You can write regular text in this sort of stuff. So I can say, hello world, and then we give it a moment, or we hit save it to boost it along, and there we go. See, it says hello world right there. So you can use this thing as a regular sort of text editor, and I actually prefer it because to things like Word, because it's much more flexible and there's a lot more power in terms of the formatting and how you want things to look. What's also nice is you don't have to be so precise with how you write stuff. Let's say I do that and say hello, all sorts of massive spaces world. Boom, it didn't change anything, it looks exactly the same. And that's because it knows to auto format one space between words. And similarly to auto format two spaces after sentences. How are you? Okay. If I want to put spaces in there, extra spaces, it's slash space slash space slash space slash space slash, or let's do one. Every one of them will represent an extra space. Yep, and you see that moved over a little bit. And if I want to start a new line, slash slash will let me, this is the next line. Great. Without the double slash here, these two would be touching. They'd be right next to each other. But with the double slash, I put this blank space here. Otherwise, there we go. All right. I like to have a little extra space. So let's start doing some math then, huh? So very basic things. Anything you want to be expressed as a math statement and not in English, you want to put between dollar signs. So let's consider the character X, and let's compare that to uh, maybe the character X inside of dollar signs. And if I compare these things to each other, oh, you see how the X in the dollar signs is slightly italicized. That's uh, that's in the math format that you're used to seeing in textbooks and presentations and papers and that sort of thing. And so when you write math, you want to write it inside uh, dollar signs. If it's something particularly important, let's say what's a very, very important math fact that say a group G mod by the kernel of F is congruent to the image of F, then you put it in $2 signs. And what $2 signs does is it centers that equation in the middle of your document, and those are for for things that you really want to emphasize. So a group G mod the kernel of F is isomorphic to the image of F. That we should all know that that's a very, very important fact. It's the birth of modern mathematics, as far as I can tell, and so therefore the most significant fact in the road. Now, I have a bunch of customized stuff that I've written over here on the side. Again, it's best to ignore most of this, but there are some useful things here, and I'll probably refer to some of these commands. You don't have to really pay attention to much of this, but some of the things like the slash cur here are things that are written up here, and so they're not standard, but just to get your feet started, just to get started, uh, if you just follow along with what I do here, you'll be fine. No one ever builds a tech template from scratch. Everyone just ends up borrowing a template from someone they know, they copy and paste it, and they edited it over time as they get used to the language. So, some other things that are sort of useful. If I want a fraction, you can put the thing you want at the top and the bottom inside the two braces here, and that will give you the form of that command. Wait for it. Oop. See, top, bottom, and it's all italicized because it's inside the math format. Limits, the variable. Caps to by accident. And see, it gives me an error because it doesn't know what that meant. The limit, the variable in question. And the its target. Let's save that. Oh, I don't think I have limit as one of my custom commands here. So let's change that. Let's just say lim sub x to 0. Right, and that would give me the limit as x goes to 0. If I want to make that look nicer, I can say display style here. And boom, the limit is x approaches 0, and you can write whatever you want here. So when you put things in the caret, then that you here e to the x makes it an exponent. If you put things with the underscore, that puts it as a subscript. And then wait for it. Save 8. So here we have e naught to the x. Now if I write e naught to the 2x, what it will show is you have a second here. See, it'll say e naught squared times x. If I want the whole 2x expression to be an exponent, then I need to brace all of that up. There we go, e naught to the 2x. And you can embed environments in environments. So let's say I want e to the 2x cubed. I can just go ahead and say e naught to the 2x cubed. And we'll see that reflected there. All right. Another useful environment is the equation environment. So begin equation array star and equation array star. And what this will let you do is wait, hold on. Is it will allow you to create an equation that's centered in the screen, and you put the ampersands on both sides of the equality relation symbol in the center, and then I'll put 2 plus 3 on the one side and 5 on the other. And what's nice about this array is that it will line up all of the equal signs as long as you put these 2 ampersands on both sides. And this is for longer-ish computations. So let's say I want the limit as x approaches 0. And by the way, copy and paste really is your friend here of the fraction x e to the x over sine of x is equal to, well, by L'Hopital's rule, we know that that should be equal to the fraction. Derivative of the top is x e to the x plus x, and at the bottom we will have cosine of x. Right? X e to the x is x e to the x plus x. Sine becomes cosine. This is by L'Hopital's rule. And if you were working out something really detailed, we could then say, oh, we can evaluate that at 0. And so I'll just copy all of this. And then we realize, oh, I don't need the limit anymore. That's 0, e to the 0 plus 0, cosine of 0. Save that. All right, we plug 0 in. That's 0. That's 0. That's 1. Oh, that's really stupid. That's e to the 0 here. So you can go back and fix mistakes that you've made. And it gives me an error because this frac doesn't mean anything. So that's 1. That's 1. That whole thing's 1. There we go. See? No biggie. You don't have to put equal signs into the array, and you can insert text too if you want. So if I want to write text in this environment, even though it's a math environment, I just write /text. And so for example, I could say Dr. P is ampersand greater than text Dr. L. Hassan. Save that. There we go. It is now a mathematical fact, like everything else written here. Okay. Another useful environment are the enumerate environments. I use this. You guys have probably seen this on tests or homeworks or exams I've given. The nice thing about this environment is you don't have to remember what's labeled what. And if I just begin a enumerate item and start with an item, and I just say the first item, typo here, save that. Then I can blah, 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 write whatever I want, putting math in the middle, whatever I need to feel like doing. Save that. There you go. And if I need to add in a second item, or third, boom. All of that's there. It's automatically labeled. It's automatically aligned. It's super nice. So let's go ahead and try to write some stuff that you could conceivably see in your classes. I think we know enough to do something like that now. So let's begin, and I have an environment that I defined up here called problem. So it doesn't know what it's beginning. So let's say begin problem, end problem. And so our first problem is going to be let f from x to y and g from y to z be continuous functions. Prove that g circ y is continuous. If you're not used to what all the little symbols are, remember that LaTeX is used by millions and millions of people, and so like 5 seconds on Google will yield all of the information that you need. So here we have problem 0.1, that f from x go to y and g from y to z be continuous functions, and prove that, g composed with f is continuous. There is no. All right, seems like a reasonable problem. So we begin the proof of that. And right, it starts with the proof and it even puts the nice little end of proof symbol there at the end. So how would this go? We say let O be an open set in Z since G is continuous. That means the preimage G inverse of O is open. Let's delete that L. Then, since F is also continuous, the preimage F inverse of G inverse of O is also open, and therefore G circ F inverse of O is open, and G circ F is a continuous function. Sorry, Dr. Al-Hassan, if you meant for this to be a homework assignment, I've ruined it. But, there's a lot of details that could probably be filled in here, and I'm leaning on the topology pretty hard. So if that hasn't been covered as much, then there are other ways to prove this. All right. And one more example, just to kind of use some of the other commands we've defined here. And by the way, look, all of that is exactly what you wanted to read here, right? Let O be an open set in Z, blah, 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 blah. Since G is continuous, G inverse of O is open. And since F is also continuous, preimage of F inverse, G inverse of O is also open, and therefore G circ F inverse of O is open. There's a jump here. You might want to fill in some of these details and think about why this means that. That's worth thinking about. And once you have this is true, then G circ F is a continuous function. And see, by putting this in here, it automatically relabels the second problem here, problem 2, whereas this problem here is problem 1. So later on, if I were to cut and paste this problem, put it before the other one, it would reorder those things. So prove that the sum slash dsum sub I equals 1 to n of 2i minus 1 equal I squared. Sorry, n squared. I.e., prove that the sum of the first n odd numbers is n squared. And look over here, the sum from I equals 1 to n of 2i minus 1 is n squared. All right, so you probably remember that this is a proof by induction. So we proceed via proof by induction. And so here, I wanted to do this so I could show off the enumerate environment and why that might be useful here. Because, induction has several steps. So the first step is we first show that this is true for n equals 1. And we just note 1, 2, 3, 4, double dollar signs, 2, 1, minus 1 is equal to 1 squared. We're done. Yeah, that's when n is 1, right? Then that's the only thing that happens. So what's the next step of induction? We say, hey, typo. We assume this statement is true for n equals k. And if we wanted to be really precise, we could say, in other words, what we're actually assuming is this statement when n is k. So again, I could copy that, paste it, and then k. And this is not something that I'd be willing to do by hand very often and rewrite these statements, but with copy and paste, I certainly don't have a problem with it. All right, so that's what we assume, and then we prove this is, we now prove this is true for n equals k plus 1. So let's put a little double slash there, and we say, all right, note let's put our equation environment there. So what happens when this thing is, I don't like no, let's consider, and let's take the left-hand side of this equation for k plus 1. So again, I'm going to use my copy paste here. I'm going to say, well, let's consider the sum of this whole thing, k plus 1 of 2i minus 1. That's going to be equal to that sum of 2i plus the k plus I term, which is 2k plus or 1 minus 1. Which is k squared plus 2k plus 2 minus 1. And I'll put a couple spaces here, and I'll put in some text, and I'll say, by induction, in case anyone's following along, right? This replacement here, this k squared, came from this thing, which by induction we assumed was k squared. There we go. See, k squared plus 2k plus 2 minus 1. And of course, that's equal to k squared plus 2k plus 1, which factors into k plus 1. which is exactly what we want to prove. See, you can also clarify this whole thing by saying here that, in other words, we want to prove this true. What you're trying to prove is that this statement is true for k plus 1 instead of k. So we could say k plus 1 here. And of course, instead of k plus 1 here. All right. It doesn't like to have the line breaks right after double dollar sign, i.e. the statement when n equals k plus 1. Oh my god, what's your problem? Oh, I see, I have a typo there. There. So we have the inductive step, or the base case, the induction step, the proof of the induction, concluding the proof. So this is our proof by weak induction. And then if I were to take this whole mess, go all the way up here, cut this guy, go up here and paste it, right? Now that's problem 1, and this is problem 2. And if I were to put like 100 enter signs in between, that's not 100. Just write some random crap at the end here. Then great. There's no extra gap here. Again, it auto formats. And so this lets you, if it helps to have a clean sort of canvas to look at and not be distracted by all the other stuff that you wrote, then yeah, you can just format it however you feel like. The tech will automatically make it look optimally nice. So, well, that's my initial demonstration for you guys. I hope that you enjoy it and that I hope that it's helpful. All right. Talk to you later.